Welcome, this is Rehana Sheikh, a faculty of A.A.Shah, Young IAS. Our today's topic is DNA. The full form of DNA is deoxyribonucleic acid. So, let's start to know what is a DNA. It is an essential molecule for life. It acts like a recipe holding the instruction telling our bodies how to develop and function. What does DNA stand for? DNA is a short for deoxyribonucleic acid. And what is DNA made of? DNA is a long thin molecule made up of something called nucleotides. There are 4 different types of nucleotides: A for adenine, thymine, cytosine and guanine. They are usually represented by their first letter. A for adenine, T for thymine, C for cytosine and G for guanine. Holding the nucleotides together is a backbone made of phosphate and deoxyribose. The nucleotides are sometimes referred to as bases. DNA Life's Instruction Manual. DNA is a record of instruction telling the cell what its job is going to be. A good analogy for DNA as a whole is a set of blueprints for the cell, or computer code telling a PC what to do. The rungs are very special. Each one has a name, but they prefer to be called by their initials, A, T, C and G. They don't like to be by themselves, so they always pair up with a friend, but they are very choosy about their friends. A and T, adenine and thymine, are best friends and always hang out together. Guanine and cytosine, C and G, are best friends and always hang out together. Different cells. In our bodies have around 210 different types of cells. Each cell does a different job to help our body to function. There are blood cells, bone cells and cells that make our muscles. How do cells know what to do? Cells get the instruction on what to do from DNA. DNA acts sort of like a computer program. The cell is the computer or the hardware and the DNA is the program or code. We are all made up of trillions of cells. There are around 2.5 billion cells in one of your hands. But they are tiny, so tiny that we cannot see them. If every cell in your hand was the size of a grain of sand, your hand would be the size of a school bus. So each cell has its own job, just like humans do. Some cells help us detect light and see. Other cells help us touch. Some cells help us hear, other cells carry oxygen around, other cells help us digest food by secreting enzymes. There are over 200 cell types in the body, that is 200 different jobs. But how does each cell know what job to do? Well, how do we humans know what job to do? Someone tell us. Like this, our cells are also told what to do, but not by a person or a computer. Our cells are told what to do by a very special molecule called DNA. How can 4 letters make something as complicated as a human body? Let us take a trip back to my favorite childhood toy, building blocks. Now give a child a box of building blocks with 20 lots of 4 different colors and ask them to make a tower. The size is still the same, but the combination and order of colors is different each time they build. The possibilities are endless. Well, not quite, but still quite large. Remember, it is a sequence of letters, order of the color in this analogy, that stores the information. With over 3 billion cells, each with a specific job, your body is a wonder. Some of the cells help you see, others give you sense of taste or touch. Still other cells allow your body to jump, run or throw a ball. But how do the cells know which job to do? How do they know how do their job? The answer is DNA, which is sort of like your body's blueprints or instruction book. DNA and a crime detection. Today you cannot watch a crime show on television without seeing investigator request a check swab for suspect in order to analyze their DNA. So the sequencing of DNA was successfully accomplished in the 1950s. DNA was not used in criminal cases until more recently. The first use of DNA found at a crime scene occurred in Britain in 1986. DNA is proving to be more accurate than fingerprints identification. But another major advantage has been the fact that this DNA evidence is being saved. Throughout the United States, a good number of court cases are being revisited as advocates for prisoners re-examine the cases and bring them back into court. If it is revealed that a prisoner's DNA did not match that left at a crime scene, the result has been the freeing of a good number of wrongly convicted prisoners. Some interesting fact about the DNA. About 99.9% of the DNA of every person on the planet is exactly the same. It's that 0.1% that is different, but that makes us all unique. The double-helix structure of DNA was discovered by Dr. James Watson and Francis Crick in 1953. If you unravel all the DNA molecules in your body and place them end to end, it would stretch to the sun and back several times. So DNA is organized into structures called chromosomes within the cell. DNA was first isolated and identified by Swiss biologist Friedrich Miescher in 1869. So I hope you enjoy this session and know lots about the DNA. Thank you so much for watching. This session is presented to you by A.A.Shah's Young IAS. Next time we will come back with one another different and interesting topic. So keep watching. Thank you so much for watching.